Okay, this is my BSR turntable, and it looks like I've got a problem with this. I took this all apart, I degreased it and cleaned it, and then re-greased it, and I made a mistake of, for instance, this piece right here. Oh, you can't see that. There's a sliding bar right here, and I put too much grease on it on both ends. Although that may not have been my problem child, but this is. This right here, I'm going to rotate this around. This piece right here drives this tone arm using a nub that's over here. How this works is this arm right here, let me move this around so you can see it, and we'll back out some so you can see. This arm right here moves, and as it moves, it drives this part into this part, and depending on what's going on, this little piece right here, which I'm going to take out in a minute, drives the tone arm to where hopefully it's supposed to be. And this is one of the things I greased that I should not have greased. Let's see if we can get this out of here without losing it. Let's see here. Alright. Now, it looks like there's still some grease on it. I'll have to look at that because I thought I had it cleaned off. This little piece, it's got a cutout in the back. Oops, got a cutout in the back because there's a stop back here that keeps this from rotating too far. Although it can actually, when it's mounted in the turntable, it can actually rotate too far this way, and it locks up the whole mechanism when it does. That's a bad thing. It's also a bad thing that I still seem to have grease on here. This has to be dry, completely dry. If it isn't, then these are the kinds of problems that you're going to experience. It won't drive the tone arm where it's supposed to go. And what's supposed to happen, let me just drop this down for a minute and I'll show you what's going on. Alright. Let's get out there so we can show you stuff. And we're going to have to bring this down a little bit, I guess. And alright. Alright, so when this arm is down, what's supposed to happen is if you hit the reject lever, this arm should come up, should go over like that, come back over and sit down. What's happening right now is the arm is coming up, is going all the way over here and setting itself down here because the arm isn't being brought back, which is obviously not what you want. And the reason for that, and I don't know if I can show you or not, this is going to be hard, very hard. Can I? Is there anything I can show? Oh, alright, maybe. Let's see, zip back in there so I can see if I can get you some kind of a picture. Yes. Alright, so if you see these ratchet poles here, these are what are used to set this to set down at see, is it 12, 10, and whatever the 45 is, I forget. So anyway, there's 3 positions on this, and there's an arm here, a little plastic finger on the front of this that detects the size of the record, and when it does, it makes sure that this arm catches the right pulse so that the arm can only travel so far. Now, when you slide this piece down, though, this arm right here gets repositioned. If you notice, I don't know, can you see this thing? Yes. This pawl right here is the one that's supposed to stop this arm from going back out onto the record once the last record is played. The problem is, like, maybe I can show you what's going on. Alright, well, I didn't want to do that, actually. Maybe I did. Alright, so, right now you see this pole. I don't know if you're able to see that well enough or not. Yeah, okay, let's try that again. So, when this arm is coming back, it's played the last record, it's coming back, it's supposed to hit this arm right here and be driven past it, and then latch so that it can't go back out onto the record. And that's not happening. And the reason it's not happening is that little part that I just showed you. Alright, so let's... Alright, this is that moving arm, which you can't really see. Alright. Alright, now we've parked. So, what I've got to do is see what's going on. Why are you still greasy? Where did the grease come from? I thought I had it clean. Well, we're going to go cleaning. Both this and the other part. And let's see, I think it's going to have to dig out some Q-tips and some degreaser. So, I'm mentioning this because, well, I bet this is a very easy mistake to make, because you're going through and cleaning, you just kind of figure everything should get cleaned and get greased. And there are certain things on this that do benefit from grease, but there are some that do not like it. And this is one of them. I'm going to show you another one that you might want to be careful of. I don't know if it's gotten clean enough or not. Let's do this again. I bet I'm right. Yes, I am. Okay. Alright, so what I'm doing is I'm spraying degreaser on this, and I just saw that image go very, very blurry. Alright. Alright. Now, let's go back to this. And get this cleaned up. Yeah. Now I got grease all on my fingers. This is bad. I do not want grease on my hands when I'm trying to degrease things. Alright. Let's see. Okay, so let's clean this off. Make sure I get it good and clean, good and dry. Now, I have this industrial strength degreaser. It's a WD-40 product. It works, and in some instances it works really well. In other instances, I'm less than crazy about it. It doesn't dry quickly. I wanted something that would be low residue. It says no residue, but I guess it depends on how long after you've sprayed it whether it's residue or not. And it's not bad degreaser, but I really wish it would dry sooner, and it just feels like it's leaving. It's almost like it's got kind of an oily feel to it. But once it's actually completely wiped free, then and actually what I want to do is, I've got, oh, that's annoying. Don't do that. Stop it. Alright, so what I want to also try is, well, where did I put that? Oh, there it is over here. This is also a WD-40 product. It's a contact cleaner, and it's also supposed to be a low residue. And this one, I like actually okay. The reason I bought this is because some fiber materials, such as the kind that actually support contacts and things in various switches and well, rotary switches is one thing that I've run into this with. If your cleaner, contact cleaner, leaves residue behind, and say that there's a 120 volts on this rotary switch, the possibility exists that it's going to arc. I've actually seen it, and I don't know if it was my fault on one of these items where the on-off switch is actually on a tube tester. It arced between, yeah, okay. So you had two contacts, and the finger would slide, maintaining contact with this one, slide over here, and now both of these were connected and make your on-off connection. When you would turn the switch off, it would come back over here and turn it off. The only problem was that the material in between had become carbonized, and there was enough of a resistive effect between these two that the on-off switch would never turn the unit off. And then when I dug into it, I also found that it had started burning holes through the fiber. So I had to clean all the dead stuff off, and I used epoxy to fill in the holes, and I had to do a number of things to correct the problem. But I had another instance where it looked like the another rotary switch. This was lower voltage, but it looked like there was some resistance there that was causing a problem. So that's what I thought was happening. It may be possible that there's something else going on. I'm not sure. But one thing I have learned is that when you're dealing with those switches that have fiber material in them that support the contacts, it's the best thing you can do is not leave any residue whatsoever on there. So just be careful of that. Now I think, can I get my finger in there? No. So let's I want to make sure that this is reasonably as clean as I can make it. And yes, I had a Q-tip in here earlier, but this is just further checking to see if it really is clean. Let's see. All right, now can we go in there? Fine. Oh, that's being annoying. There we go. All right. Now the only way I'm going to know if this works is if I actually test it over and over and over again, because this thing does not consistently fail. And it's puzzling how it can have enough force to drive past that latch on one occasion. Oh, that's not what I wanted to do. Now give me a moment to find that clip. This again, I'm going to be brave. I'm using a different pair of pliers, wider build. Hopefully I can get this on there without spitting it across the room again. It's amazing how far these things travel. They can be mighty annoying. Oh, don't do that. Come on, get in there. Alright, now. I think it's in there. Alright. Wider bill pliers work better than these skinny little things. I should know better. Alright, so now the other thing that you've got to know is that this, well, especially when you've worked on, yes, this is the bad position for this to be in. Oh, I think I screwed up. Here we go. Alright. Whoops. Maybe, come on. Am I in the right spot? Alright. The opening of this is facing out this way. So what I have to do is I have to shove this back around. Uh-oh. Oh. Yes. Wow. Wow. That is really snug. Whoops. Of course you can't see what I'm doing. So anyway, this, if you leave this arm, if you leave this opening facing this way, well, let's see. Back out again so you can see. This opening here can't be facing this way. You still can't see. This is hard to do. Alright. The opening right now is facing this way. It can't be facing this way because the side of this piece will hit that nub over here and it will lock the whole mechanism up, which is clearly not what you want to do. Let's see here. Let's zip back out here. I've discovered it's very hard to try to see what's going on. So actually what I want to do right now is I'm going to make sure this is unplugged. Yes. I'm going to do this. Whoops, no, I didn't want to do that, but well, I did it already. Alright, well that's going to test it anyway. This is going to see. Oh, no. Oh. I didn't get it far enough. Ah, there we go. I think. Let's go. Oh, right. This is also why you do not just power it up when you've worked on it. Just hit power and let it go, because this is what happens, what can happen. You can get really jammed up. So I'm going to actually just tap this loose. Hopefully I can do it without wrecking anything. Yeah, that is a whole lot stiffer than it was before. Trying to hold this in the air and hold this and all that stuff. It's not cooperating, so let's get some fingers over here. So what I've got to do is drive this loose. Come on, let go. Yeah, it's probably not recommended, but there it goes. Alright, it's free. Okay, it's another thing not to do. You really should look at it and see what it's doing. Oops. Alright, now. There it goes. Alright, so what I'm going to do now is I'm going to rotate this over. I'm going to rotate this, and it's going to try to eject. And then I've got to watch and see if this part right here goes past the latch. And it does. And you've got to be careful with this, because once it's all done, that tone arm can then freely move about, and that would be bad for your, that would be bad. Wow. Well, this piece in here that I took out and cleaned is significantly stiffer than it was before I took it apart and cleaned it. Wow, that is just amazing. Just a little bit of grease. So next, what we're going to do is, because I'm not convinced that this stupid thing is fixed. So I fixed this several times, thought it was all set to go, and well, you know the moral of the story, it wasn't. It was not set to go. So, this is the fun part about working on turntables, trying to get them in the air so they cooperate. Now, I'm going to do one last manual test, and I'm going to just, okay, there it is, good. Now we're going to pretend that I've turned this on, it's playing the record, and I'm going to move this over, make it eject, and now, of course what it's supposed to do now, sit down like that, and it does. Okay, so now we're going to do it with power, because if anything, if that's, yeah, if it's going to screw up, that's when it's going to do it. So, wait till it picks up. And we're done. What's one of the funny things that this thing does is that it does actually turn the turntable off, but there's enough momentum from the platter that this arm will continue to go back out here, and this isn't set up to turn anything on or off as far as an amplifier. So this thing winds up, sets it down on the record again, and hear it wind down. It's very, very weird. But anyway, okay, so yes, I think we have it. It's behaving much, much better. I mean, that part in there is much stiffer than it was before I took it apart and cleaned it. And I don't know how grease got on that part again after I cleaned it, but it did. And grease is the enemy of that part. Yes. One more time and I'm going to call it fixed. So, I've shown you several things what not to do, and one is to not, one thing to do is when you're manually rotating this, you need to be looking underneath there at that pawl and making sure that that opening is indeed going to clear that pin, because if you don't, you lock the whole thing up like I did. I wasn't exactly excited about smacking it the way I did to free it up, but that thing was really locked. And I've cleared it before by turning the turntable in reverse. This, oh come on, I may not have a needle before I'm done fixing this. Yeah. So, just so you know, the opening of this part should be facing, you've got this pin right, this rod here, the opening of this thing should be facing to the left of this. and you know, if you put your screwdriver in there, it almost is. It's not quite centered on it, but how can I explain that? Actually, this pin right here, if you look at it, if you were able to get something centered on that opening, the center line coming through that opening would be just a little bit to the left of this. And you can have it a little bit further than that, and it will adjust itself to accommodate what it needs. If you have it to the right of that, however, that's where you get into trouble. What happened to me is I had this lead edge just barely out of position, and it came over and lodged itself against the pin, and it was not going to let go. And I couldn't back it up. And there are probably things I could have done. I might have been able to reach in there and pull the drive wheel free and back it up. But a delicate smack with a screwdriver took care of that. So when you're working on these, just make sure you make that opening where it basically to the center, you know, aimed out to the left of this pin. If you have it aimed out this way, this pin will hit the side of this and it will lock everything up. And if you've decided to just test it by putting power to it, your rubber tire is just going to sit there burning away on the motor, and you need to move very quickly and turn it off, because you don't want to wreck your idler tire. Okay, so I think, oh, the other thing is this arm right here, this needs to be free. I think this was ultimately my problem, but this was actually sticking a little bit too, and I think it may have been, well, on this end of it, it goes up inside and it goes underneath a gear, a large flat gear drive. There was a lot of grease on the top of this part right here, and that was not ideal. This should be freely moving like this. And one of the things you do not want to do is you don't want this stuck forward, because then it will constantly try to eject. Because this is the thing that actually activates the eject mechanism. When this is driven forward, it drives a little pawl on that big gear that's under the turntable, under the turntable platter. It drives that little pawl out, and then as the platter is rotating, the gear engages that pawl and then activates this whole mechanism. So two things to be careful of on these, this and that. So I will be testing this now to see if it's reliable. I actually ordered a manual for this, and it turns out maybe I didn't need it, but you know, it's nice to have, because if I run into other oddball stuff that I'm not familiar with, then I'll know. And there's probably things that probably the manual will tell you stuff like, don't grease this, don't grease that, and stuff like that. When I got this, pretty much everything on it was gummed up to the point where nothing was working. In fact, there was stuff in this area that simply would not move no matter what I did. And in fact, at one point, because nothing was working, I actually took this stuff, heavy duty silicone, and I sprayed that section where that part was not moving, and that freed it up. I think it was right in here somewhere. I don't remember which piece it was. It might have been this piece right here. Oops. There's a part that slides underneath this other metal plate, and I could have, you know, I tried hitting it with degreaser. I actually went out to the garage and got my heavy duty degreaser, and this thing just kept binding. And ever since I sprayed it with silicone, this part has not screwed up. It's behaved itself. Can't say much about this. That's the other thing, though. If you're spraying stuff in here, and you've got stuff that's sensitive to being lubricated like this, be careful how much you spray and where you spray it, because if you hit this with silicone, this part right here with silicone, you won't be happy because it will be way too slippery. So anyway, this is just a short little blurb on a couple of things to do and not to do with your BSR turntable. The model on this one, just for anybody who might be at all interested in this, is a UA15SSA-3D. And I do see these for sale out there at times. They are, well, let me just tell you up front, one of the things I don't like about this turntable. This right here, on more modern, or on different models, probably more modern, when the last record drops, well actually as each record drops, well, here's how it works. The plighter's turning, the arm lifts, this thing that gets activated. The record drops and drives this down to the appropriate size of the record, which tells this where to stop. Once the mechanism has finished doing what it's doing on this turntable, this arm doesn't stay down, it comes out and stays there. There's no latch. I went looking for that. Some more sophisticated turntables, probably newer turntables, once the record has dropped and pushed this arm down, it stays there until this arm hits the end and does its return. And while it's doing its return, this arm flips back out, another record drops down, hits this and drives it down, and it stays there. Which is obviously the preferred way of having that do it's what you really want it to do. So, just looking, I think there's supposed to be a ring in here that, I know there is, there's supposed to be a ring in here, probably says BSR. Mine is long gone. And there's probably no way to find one. So in order to get your records off, you have to reach over here and then grab your records and lift them off, keeping this out of the way. So you kind of have to do this kind of a number, because if you don't, this thing interferes with you getting records off from the spindle. Sometimes if there's only one, you can sort of get it around it. I wouldn't recommend that though, because you could wind up scratching the top of your record, which I think I almost did that at least once. It's not a bad turntable though. I was able to adjust the tracking to the point where I was happy with it. And it's got an adjustment under here for, well, there's a screw under here that allows you to adjust this way so that you can tell it where it's supposed to land on the edge of the record. I just remembered actually I need to tweak that slightly because it's just a tiny bit off, and sometimes it hits the edge of the record when they have a kind of a curled lip, and it skids down onto the first track of the record, which obviously is not what you want. You want it to drop on the edge of on the starting lip without skidding onto the record, which is obviously bad. If you can get one of these reasonable, they're not bad. They usually get gummed up pretty badly, so just be prepared for that. Unless somebody's worked on it before you, you're going to wind up having to do some serious cleaning. And this one, I have no idea. Actually, I think this went to, I think it was that Morse radio that I had on another video I did, and that radio is probably mid-60s. So the grease, yeah, I knew you were going to do that. Yep. It's doing this because I was playing with it, and it triggered that slide bar that I was playing with. Yeah, that's what that does. It triggers the eject mechanism. So just a reminder, when you are working on one of these, before you put power to it, manually rotate your platter and make sure that things are working right. Otherwise, your motor's just going to sit there burning away on your rubber tire, and you really don't want that. And I think that's all I want to mention in this video. This is probably going to be quite short. But I also hope that this helps somebody who's got a BSR and who has made the same mistakes as I made. Oh, well, while I'm talking about this and doing this, let me show you that gear I was talking about, and that interferes with this. All right, this is that gear, and there you see here. No, maybe you don't. This groove right here, there is a little pin that follows this groove, and that's what actually drives the mechanism behind when it's doing the eject, the process of ejecting and moving the tone arm around and so on. And I greased this pretty well, but I also made the mistake of putting too much grease, and a lot of grease got on the back side of this, and then it got onto the top of that sliding bar that I was showing you earlier. And I don't think that's the best idea. The grease that I used, I was experimenting with, and I'm not happy with it. It's too thick. I think at some point I'm going to be trying sewing machine grease. I want a nice lightweight grease. I've got some ancient grease from my days as a typewriter repairer, but that stuff is old, and you can smell it. And that means that its life is going to be relatively short. It's still thin, and it still lubricates, but I'm less than thrilled with using that. So that's the other thing about working on this stuff. You don't really want a real heavy grease in a lot of places on these. This might be happy with a heavy-duty grease just in the groove, but you pretty much elsewhere on this you don't want that. So, and I'm thinking probably just a lightweight grease would also work for this. I'm not an expert on these, but that's what I would guess. It would certainly avoid the problem of getting a heavy grease that's kind of sticky, getting on the top of that sliding bar and causing it to not behave as it ought to. And by the way, this is the part that bar hits. Normally, once it's done its job, this goes back like this, but then once the bar comes along, it shoves this whole mechanism out, and the platter has a gear on it, and it will grab this pawl right here and then activate this gear and make it drive. So I think that's pretty much all I really wanted to look at. Yes. So I'm going to bail out right now, because I don't think there's anything more I can show you or tell you about this. There are manuals available for these. I think $14 or $15 with shipping. That's what I paid for the one I'm getting. So they're not outrageously expensive. So if you have one of these and you're running into trouble and just don't know what to do to fix it, getting a service manual is probably not a bad thing to do. I bought it even though I thought perhaps I could figure out what was wrong. But there are things about this mechanism I don't think I've entirely fully figured out. So it would be nice to know some of those things that I'm not entirely aware of. And if I run into trouble with another turntable, I might be able to get some ideas about what might be wrong with that other turntable, possibly. So anyway, I'm going to bail out. Thanks for watching if you have, and hope to see you on the next one. Okay, well, I'm going to do a little bit of an addenda here, rather than refilm the whole thing. This arm starts here, the top, goes all the way down, goes past this, hits the on-off switch, and then comes down here, and this interacts with the position of the idler wheel. I think when you have this part, it takes some pressure off the idler wheel so it won't flat spot. I think that's what that does. But this arm is activated by your on-off control, on manual reject control. And this, and if I got this plugged in, I don't do that. So this, when you move this, it comes over here and hits the on-off switch. So this is important. I had put a different kind of grease on here, and I was really not happy with the results. This was way too stiff. You've got a spring here, and you've got a spring here on the on-off switch. But this was way stiffer than those two springs could account for. And the problem with that was that the control, this control right here was way too stiff. And now you notice, I don't know if you can tell, but that moves very freely now. When I got this, that was not the case. In fact, I didn't really even want to use this plastic handle to activate or to move the mechanism because it was so stiff I worried about breaking this off. Same was true over here with the speed control. So when you're working on one of these, make sure that these two controls move pretty freely, because you know this is old vintage plastic and these could be fragile somewhat, and you definitely don't want them to be very hard to rotate. So that's probably the only thing that you would have an issue with if you went with a really heavy grease. And I put grease behind this pivot point right here, but I have some lightweight grease that I've been, it's old, so I'm a bit reluctant to use it, but it seems to hold up well, and it seems to be just the right consistency, because once I got rid of the grease that I tried on here and put this on, then this behaved a lot better. So I think that's all I really want to mention in this part. Alright, well, I guess you could call this the addenda to the addenda. Adding on more stuff. I wasn't planning on doing that, but I violated one of my own rules. And my rule is, when you get really tired, stop working on stuff. The problem is, you get into something and you really want to keep pushing on, and you really want to keep going, and even though your brain has stopped working, you still think you can do it. Okay, so these are two different circuit diagrams, and what this is, my BSR changer, the wiring that I'm showing you here, from this part over is the changer. From this part over is an amplifier that I'm using with that changer now. One of these two wiring diagrams doesn't work exactly right. I'm going to give you a minute to look at these and see if you can figure out which one doesn't work right. I got so frustrated, I actually wired up, well, let me back up. You notice the power is going into the amplifier. I actually wired up the power going into the changer because that's the only way my very tired brain could figure out how to make this thing work without doing what I didn't want it to do. But I kept thinking about that, and I said, that doesn't make sense. They had this wired up. That BSR was part of a console, and I believe that Morse radio was also part of that console. There's zero information on it, none whatsoever. I tried, you can't find a thing. The BSR, probably more chances that I actually have a manual coming for that. Let me explain the problem I was having and the part that's frustrated me. The minute I would plug the power cord in, the motor, this is motor, the little motor in the changer would run. I said, that's not supposed to be, I don't want the motor running all the time. And so I'll let you in on the I'll reveal the answer. This is the diagram that doesn't work. Now, what's interesting about this is that this amplifier did not come with this changer, and the color code on these wires is, well, they use the same colors, but they aren't. They don't match what should be over here. So I had red hooked up to red, and black hooked up to red, and yellow to yellow. And I think there's another wire, but in any case. Unfortunately, the amplifier was not designed for this. I don't know what it ran, I don't know what it went to, what turntable it went to. And I think the amplifier is older than the turntable, because I think that turntable may be close to the mid-60s, and the amplifier is like a 1959, 1960. So there's a little bit of an age gap there, and it wasn't made for this changer. So, but I thought, oh great, the colors match. Good job. So I hooked it up and ran into this stuff. And I was looking at that and I said, well, this switch is open, that motor should not be running. Why is that motor running? I don't know why that motor's running. It shouldn't be running. One of the things I didn't do was draw a circuit diagram. I was probably too tired to even think of that. But if I had, I would have seen something rather important. And I did measure with my meter, and I did discover what the schematic actually reveals. And some of you have already seen it. So you've got a transformer here, and you've got a transformer here. Follow the path. This side of the power goes up here, goes over here, through this transformer, down over here, and through this transformer, and down through here. That, my friends, is a complete circuit. And the resistances involved here are low enough that there was full power available to run this motor. When you plug this in, you have made a complete circuit here, supplying full power to both of these transformers. And actually, I'll bet you the power amp was turning on at the same time. I didn't pay attention to that because I just saw the motor was running. But yeah, it makes sense. There was full power flowing through this, so by plugging it in, you're turning on the amplifier and the changer. So I said I pounded my head against the wall because I was way too tired and not clearly thinking. So later on that night, I just said, well, I can't do anymore. I got it working. I'm just going to go to bed or something. But later on that night, I started thinking about it. I said, you know, it's got to be wired wrong. You need to go back and look at it. Because I had it working with the power connected to the changer. And I said, no, that's not right. That's not how it was designed. So I thought about it, and it boiled down to just swapping two wires. I had these two wires swapped. And when I put them where they're supposed to be, you'll notice something. Now these two transformers are in parallel. There is no power. This power light comes up, goes to the on-off switch. There is no way that you have a complete circuit here. So there's no power here. You have potential power here. This power comes up, goes to that leg of the transformer, and that side of the transformer. You have potential power, but until this switch closes, you just don't have anything. And so, if you're playing with something that you don't have any documentation on, and you can't quite figure out how to wire it to make it work properly, and you've got an amp and a changer and you want to make it work, this is how you wire it. Make sure that this transformer and that transformer are in parallel, not in series, which is what this is. So, I feel a bit foolish now that I'm awake and clearly thinking, and realizing how silly that was. But this is essentially series. And of course, I allowed the color codes to mislead me into believing that I could just wire it up the way the color codes showed me to wire it up. And that's another thing to be aware of. Two different units from two different consoles, whatever. And the colors are, you know, Magnavox made this. Morris, a Japanese company, I think, hooked up the changer and their amplifier, which I have. So they had their color code, Magnavox had their color code, and the two do not match. But that's okay. The electrons don't care what the color on the outside of the wire is. They simply care that things are wired up correctly. And this is not it. So, anyway, I am wrapping this up. This is it. I'm done. And I'm hoping that if somebody is baffled about why, when they plug in their setup, they've wired it kind of like this. They're wondering why the heck everything's turning on when that switch is clearly open. Oh, I went round and round, but it can't. But no, it shouldn't. That switch is open. Why is it doing this? I feel so dense that I didn't see that immediately. But like I said, and you know, I did draw a circuit diagram, but it was so sloppy and it wasn't neat, and it didn't help me. This shows you very clearly what you did wrong. So if you do a nice, neat diagram of how you've actually wired it, I've discovered that I sometimes have to draw out a circuit diagram to figure out what's going on, because I can't seem to just look at things, not always. I'll look at something, the actual thing, how it's wired. Sometimes I do okay with that, and sometimes I don't. And sometimes it really, really helps me to actually diagram what I'm looking at. And if I had done that and done it neatly, which I hadn't done, I would have followed the trail and discovered, oh, that's why it's working funky. So, hopefully this helps somebody. Maybe I'm the only turkey who's done this. I don't know. But if not, then I hope it helps somebody. And thanks for watching.